Welcome back to my GIS lab. This is one of the very few lectures where both my PowerPoints and my class demos are put together into one. The reason is that I'm going back and forth between the PowerPoints and the lectures. That is one of the reasons why usually I teach this course in the computer lab, because you can all work with the coding and follow me in class. But in this case, everyone has their different paces. I think it's much easier if everything is recorded and you choose your own pace. So at some point later on, you will want to use the pause button quite a bit and basically follow me what I've been doing on your own ArcGIS Pro software. So Python is a general purpose interpreted high-level programming language. So what does that mean? It means it's powerful, and it means it's simple to use. So the design philosophy is there that it's readable, so that means everyone who understands the basic principles of the syntax can read the code and understand what's going on. The Dutch programmer Guido van Rossum had decided back already in the 1980s that coding is supposed to be fun. In those days, there were a number of coding languages that were just a really nightmare in terms of syntax and organization and what they could achieve. So Guido built the basis on this and then became open software, and over 4 decades became what it is today. And the name Python is truly based on Monty Python Flying Circus, the troupe that did some very wacky TV shows and movies in the 1970s and 80s. Obviously, the scripts that you learn to develop and that you may want to create on your own are there to code complex workflows, automate things, make things faster, make things more error-free. We talked about this. There's nothing new about that. Python is the native scripting language for ArcGIS Pro. While you can use other languages to automate things in ArcGIS, in which case you have to cut some corners that know more about coding, Python is already embedded in there. You have a Python window. You can translate your model builder script into a Python script directly. And also we have IDLE. And then there are other Python editors that you can use to write your script. The good thing is you don't need to be a programmer. Here's my message to those of you who are not the slightest bit interested in coding. I want you to be able to do these few basic things that you learn in this next week, so that at least you have a line item in your CV and you can say, well, I've been exposed to Python. I was able to write one script and I understand the principles of that automation. And that really makes you more employable. Coders are clearly more employable in the GIS world than non-coders. But that doesn't mean that everyone has to become a coder. And those of you who are already comfortable with coding, those of you who've taken maybe one or more computing science courses, you will like Python. I'm pretty convinced of that. I heard from many students who I hired as summer students, and I exposed them to Python, and within a few days they were quite comfortable with it, and within a few weeks they could write some awesome scripts and automate some things that they didn't think was possible. So Python is used for both the beginner and the advanced user. And it's obviously not restricted to ArcGIS. It is everywhere in the world. Or you can write apps for smartphones and any other platform that you can think about. So once you know the basics of Python, we'll start very soon, is you can automate geoprocessing workflow in a similar way how you used the model builder before. You can use it to create automatic map production. I had hired once a summer student who helped me produce hundreds of maps, all completely automated, all with their own legend, all with their own titles, all with their own parts that make up the map. And it was amazing how powerful that was and how relatively easy it was to develop that script. And then, of course, also you can do data management tasks in ArcGIS. You can set your workspace. You can change your environmental settings for a particular job. And so that all has to do with organizing things, and that's why Python is just so very powerful. So Python is free. You can download it. You don't need ArcGIS to download it. It comes preloaded with version 3.6 at the moment, I believe. It is cross-platform, so it works on Macs and Linux and Windows and other platforms. It's open source, so it always gets better. It is mature. You know, it's been developed in the 1980s, so it's been around for a long time. And it is powerful. Compared to JavaScript, according to some who know more about coding than I do, it is 3 to 5 times shorter than JavaScript. So imagine needing 20 lines for JavaScript. Supposedly you can do the same thing in maybe as little as 5 lines. And it is supposed to be 5 times shorter than C++. C++ is still the coding language that those of you who learned coding at the Department of Math and Computing Science, you would have used C++. And I have been in contact with them for 15 years, and I begged them to add Python courses. And they stick to their C++ courses. They didn't want to move ahead and change their curriculum. And that is why I have chosen to include the Python script in this course, because it is so important. It makes you much more employable. And we'll spend probably a total about 2 weeks around Python. And that is a big chunk of the course, but also it's a big chunk of empowering you for future employment. Python has several editions. We use right now the 3.6, as I said earlier. The old ArcMap used Python version 2. 2 and 3 are quite different. There is a little bit of change in syntax, and there are conversion tools to take from one and convert it to the other. And those conversion tools work for 90–95%, and there may be a few things you have to hand edit. So that means migrating older script to the newer version may be a small little hiccup that has to be dealt with. Python is very well documented. You could go to Code Academy online and learn Python coding there. There is a really good book. This book here. And the newer version is on your screen. My version is from 2013. It's quite old. But this version here was $75 online. That's pretty cheap for a book of this caliber. It comes with a CD with the tutorial material and everything else, and it guides you through step by step as if you are a beginner and you don't need to know anything about coding. And then here for ArcGIS Pro, I have also added some other links that I find very helpful. Please copy these links onto your computer and check them out and have a look. That's where you find your reference material. If you want to go do something and you don't find it here with me, well, then you go online and find it there. Older ArcGIS versions used Visual Basic for applications to help with the scripting, for instance, Field Calculator and other applications. So Python is replacing that, so often you still have both options available. But I encourage you to migrate over to Python because that is the future. Visual Basic for applications is more like the past and will likely disappear one day. All geoprocessing tools are available as Python functions. So everything you've ever done, raster calculator, symbology, layouting, mapping, any kind of analysis, any kind of join and add field and edit things, you can do basically as a Python function. And you can copy and paste between the ArcGIS Pro Python window, which will open up in a minute, and any other text editor. But the key thing idea is that you can write Python script in various ways. One way is you can write the script taking your model builder script and then saving it as a Python script. And so that's one way. The other one is going to the Python window and doing it line by line, command by command, working out your workflow, and then saving that whole script, maybe cleaning it up a little bit, and then using that as a scripting tool. Or the third option is that you use an outside scripting tool such as IDLE, and you use that as your basis for your Python scripting, but that means you have to type every command directly because it's not directly linked with the ArcGIS Pro graphical user interface. So the Python window, let's start with that just to get you used with the syntax and some key ideas before we move on to the scripting tool. Well, the Python window interacts directly with ArcGIS Pro. So instead of using a tool, you can use a Python window and do exactly the same kind of work that you have carried out before. So you can still work with layers and any kind of content that is on the map and work with that content directly and interactively. You can also use, of course, as it says here, the environment settings and add the output of the geoprocessing tools back to the map. And here is the first time we're hearing about ArcPy. We will talk a lot more about ArcPy. That is simply the module, the container that holds all the ArcGIS Python tools and all other tools that we can use in the GIS environment. And then you can derive one command at a time, or you can put commands into a block and then execute that whole block in one go. And also what's handy with the Python window is that you don't have to retype something that you've done. Imagine you're typing a long line, you're making a typo, you're making some mistake. Then you say, okay, I want to redo this. So you just hit the redo button basically and make an edit or two and then rerun it. You can use a Python script that you have collected in a text editor. After some time you found out here's some lines that are useful. So you can just keep them maybe in a text editor or anywhere else, and then you can simply copy them over into the Python window and execute them. So you don't have to type everything from scratch. And then also, as we will see, is we have the auto completion functionality. So that means if you have a tool, it makes sure you're not missing any important input before you execute it. So it takes you by the hand and helps you. So here is just a screenshot of the Python window, but let's just open one up and see how it all works. I just started a new ArcGIS Pro project with nothing loaded in. It's a blank window and I want to open up the Python window. And here's the Python window. And if you click anywhere here in the top part, nothing happens. However, your scripting window is down here. And what you have in the top here is your transcript. Either the results of what you want to do, but also your commands themselves. Let's start off by using Python just as a calculator, just to make a few points. I want to start off, and you can follow me at your own pace, by declaring a variable saying a equals 6. I'm declaring another variable, b equals 8. And when I say a times b, and by the way, the spaces are completely optional in Python. Spaces are only there for us, so we can read it better as a syntax. And so a times b equals 48. We did not declare an output variable, so it simply prints it back to the screen. Now what happened here? We declared an integer a equals 6, we declared another integer b, and we're making use of these. So if I now do a divided by b and hit space, now we have the correct result, 0.75, which is a floating point. Whenever we divide in Python, in Python version 3, the result is always a floating point. Divisions result in floating point number. Let's do something where we now do 5 to the power of 2. So we're squaring 5. Result is 25. And now let me do this. Minus 3 squared. And let's see what happens. What do you think the result should be? Is it first doing the squaring of the 3 and then adding a minus, in which case the result is minus 9? Or is it minus 3 squared, which would be plus 9? The result is minus 9 divisions and multiplications, and in this case here the squaring, they take precedence over plus or minus, over subtractions and additions. And therefore that is a syntax. If you wanted to change it, then you could do a bracket and saying minus 3 to the power of 2, and that of course would result in plus 9. I want to show you how easy it is to work with variables in this Python window. I declare one variable now. And another one. And a third one. And now watch what happens when I type in the W for width. Now, because Python anticipates that we could be using a variable here, it lists all the variables, Python variables, previously declared variables, and here my own variable, and also here some other Python commands that you can appreciate, while and with. And so now for the auto-completion, I just click on the width. I don't have to type in the whole thing. Remember, Python is case sensitive. Times, and the same thing with length. There is length, and we are done. And I hit now enter. And of course, the area now that has been calculated, the value 5 times 10 is not displayed because we didn't use a regular equation like here. And so now we have to use the print command for this to output a variable. So I say print, and then simply in brackets my variable, and there is the result, 50. So you can see here when we go, and they're called identifiers here, those variables that we have declared. So now we have a little bit of scripting done, and if you wanted to save this, you can. And you do that by right-clicking on the Python window. But if you right-click anywhere here, nothing happens. I'm right-clicking, I'm right-clicking, I'm right-clicking. But only once I'm inside the text box, right? When you right-click there, now you can either clear the whole transcripts, that's the one way of just cleaning it all up, or you hit the save transcripts, and now of course you simply provide a folder and a file name, and you will now save this as a py extension, which means you can open it with any text editor. So for you here on the slideshow, just a summary of some of those important rules we just observed. We did not really talk about the hashtag, which prefaces any kind of comment. It can be at the beginning of the line, but this part also, for instance, could be at the end of a command for you to explain to yourself or others what you are doing and why you're doing it. We see here we've just done with a variable declaration. We declared, for instance, our width and our length and our area. These were all new variables that we declared. And again, a reminder that variables are case sensitive. So in data is different from in data here. If you were to use this and type it just with a small d, then you would get some kind of error message. Here again, what we had typed in, here is our command. So just simply reminding us that we're declaring integers here, both for A and B. Another reminder that if we divide, that the resulting value is always a floating point number. And here you see that we can declare integers and floating points. We can declare variables. We can use regular algebra functions. And then, of course, we also use the parentheses, we use exponents, we use multiplications, divisions, additions, and subtractions. Here again, what we had said, basically, you can use this command here to square things or to take the power of. And again, what we had discussed here, the precedence of the squaring or the multiplication or the divisions. I want to introduce this very important command, the if command, which goes hand in hand with the else and also the elif commands. The if command works in a particular way that it ends in its line with a colon, and then whatever should be executed has to be indented. So that is how Python deals with a coding block, simply by indentation. So in our example here, we declaring a variable, just using the single equal sign, declaring the variable to be A, the letter A. And then now we're asking if this variable, this is now testing a condition, this is not assigning. That's why we have the double equal sign here. If this variable is A, then do this, in this case, print this variable. We used the print command before, print followed by something that is in brackets. This can be a variable, but in this case here it is text, and text would be in quotation marks. Variable is A. If we were to declare something else but A as our variable, then else, the same line in line with the if command, also ending with a colon, print, and then in this case, of course, variable is not A. You can add as many lines within one if statement as you want. All of these would be executed as long as they have been indented. Indentation should be either 2 or 4 or more letters. 4 seems to be the standard. So here you see one code block within one indentation group, and then here is another if statement with another code block. And again here, the equal sign, double equal sign to test conditions, and the single one is to assign values. Let me demonstrate what we just discussed. I have this code in my Word document. And as you see, I just copied the code over. It was instantly understood because earlier on I had declared A equals 6 and B equal 8. So A is smaller than 8. So therefore this is correct. Let me just make a change here and I say A equals 100. And now with the up arrow, I can repeat my block here. So the first time I hit the up arrow, I repeated the last command. And the second time I hit the arrow, now it gives me this whole code block that I had copied over. And if I hit now the enter key one time, now I'm having a blank line, and the Python window executes when you enter in a blank line. And now it says A greater than B. So that works quite nicely. Imagine we have suitability values ranging from 0 to 10. If we had no value or something we don't know about, often those are assigned a negative number like a -9 or -99. So that's why right now I have coded already here. If the value is less than 0, then simply declare it as an unknown. And then in our case here, over 7 to 10 would be suitable. Then we have marginal would be 4 to 7, and unsuitable is everything between 0 and 4. And if we had values over 10, then we would like to declare that as an error. So what we can do, we can go into the Python window, we can say suit_code equals, and let's simply say 3 for argument's sake. And then what we can do is we can actually copy this one over here and see and test how the results are. Let's look at this code here. So I'm declaring something, and then here's a new command. It's the elif command. So elif stands for else if. That is embedded inside the if command. It is shorter simply to save space, and it is optional. For our case it works, but you don't have to have an elif or an else command to carry out an if command. You can just have a one-liner, as you saw in the last page. So here I try to put these conditions into this Python script. This Python script is correct in terms of syntax, however it is incorrect in terms of logic. So what I would like you to do is copy this text over, put it into your Python window, and test it with a bunch of numbers, and then come up with an idea what needs to be changed to make this code correct. So can you find the mistake and find the solution? Let me declare a suitability code. So suit code, make sure it's spelled correctly, equals 3. Now I'm copying the other code over. This is my whole block here. Suitable is 3, so it should give us at the end of the day an unsuitable. 1 enter for blank page, second one is unsuitable. So now if I click 2 up and I change this to a 12, and now I repeat my block code, and now I'm getting suitable. That should not occur. So there's something wrong. Let's try a 5. Five is marginal, and that is correct. So the last one, there was something not right, and your task is to correct the logical error. That's all for today. Until next time.